here is the program in lecture notes 1. Let's assemble this program. Assemble simply means check the errors, and if there are none, you translate it into machine language. Those are the two passes we discussed in class 1. So I'm going to assemble. And you can see it says assembled in two passes. 1, check errors, make sure everything is correct. 2, translate it into machine language. And it is successful. We can now run. When you run, you have these windows, these two. One is the source code that shows you the instruction that's highlighted, that's being executed. And here it says the program has returned control to the operating system. That is this instruction. So I'm going to click OK. And these windows load a new file, reload the same file, step back. That means you go back one step back. Single step. That means you run the program step by step, one instruction at a time. Run means you run the whole program and it gives you the final result. So I'm going to reload. Okay. And you can also click on these variables. So let's click on the variable, not variables, the buttons. I'm going to click the var buttons. And this shows you the variables you have declared. So, oops. So I have two variables, num, that's that one, and num2, that's that one. Okay, and you can show them in different formats. That's hex, that's binary, and signed. Okay, so now let's, let me need this, right? Okay, let's run this program step by step. Oh, another thing I need to explain is these are the registers. You have AX, BX, CX, and DX, AH, AL, etc. They are the most often used general purpose registers. And then you have these registers. Okay, this is the code segment. It starts at address 0700. This is the program counter. This is the stack segment. The stack segment is in memory, you have two stacks. One is the value stack, which contains all the data in your program. One is code stack, which is the instructions. But in this emulator, our code stack and value stack is the same because it's so small. So this is saying it, and also you can see our code stacks, code stack, also code segment stack starts at 700 and stack segment starts at 700. So they are really in the same location. And here we have this ORG 100H, that means our code and our memory space will start at 100. Okay, so if you look at the very first instruction, move num to AL, that first instruction is at, okay, let's click on that. It starts at 100, okay? That's that instruction. And another thing to notice is that if you look at this here, that's our instruction, right? This is our instruction. We wrote this. But the machine will assemble it into this. Look at this. So it's 00111H. What is that? That is the memory location. Notice the square brackets. That's the memory location for the variable named num1. So let's go to that location. Okay. 111, right? Okay, that is the location, 5. Okay, right now this is hex. These are the hex values, and this is the decimal value, so 5. And our second variable, num2, is located in 112, and it's 17, and that's hex, and decimal value is 23. Okay, that's what that is. So let's click on this again. So that is the location, and notice that our second variable, num2, is in location 112H. We already told you that. You can also find it right here, 0, 1, 1, 1. Okay, so it's 700 and the offset is 0, 1, 1, 1, right? It's right here. So if we say 0, 1, 1, 2, then it goes to this value. So you can find the address here also. Okay, let's once again go back to that location. So you understand what those two brackets are. And notice that here, it also has that brackets. That's a memory location. That is registered. So here it's memory to register, memory to register. And here, this instruction is register to memory. Okay, let's single step. Let's do it step by step. We are moving the value 5 into AL. Okay, notice that that's a 5. And then we do the next instruction. We are moving 112, the value in 112 into BL. Okay, that's the second instruction, right? BL. Oh, I'm sorry. It highlights the instruction that's being executed next. That's what it will do here. Okay, so the next instruction to do is that's exactly where the IP, the instruction pointer is pointing to. Remember, our instruction pointer, program counter, always points to the next instruction to be executed. So 107, 107, that's our next instruction to be executed. Okay, add AL and BL. Let's execute this one. And the result will be stored in AL. So AL will change, BL will not. Okay, now it's 1C. And let's do the next one. Subtract BL from AL. So we will subtract 17 from 1C. And AL will change. And AL is changed, right? And the next instruction is to subtract 12 from AL. That will give you a negative number. So AL will change. And it's F9. Remember, F is 111 and then followed by 9, which is 1001, right? So that is it starts with a 1, which means it's a negative number, 2's complement. Okay, single step. Let's do the next one. We are moving the result in AL into num. Okay, let's do that. And it's done. The next instruction to be executed is to return. So let's look at our variable. Our num1 is -7. So that's correct, right? Single step. And this is interruption. This is interrupt, get out, right? And go to the bio and return. Okay, so this is what the first program is about. And notice that this data segment was not executed at all because they are data. They are simply the variables here. Okay, that's it.